All right, we are going to get started. Welcome to week 2 of SQL and Python for Analytics. Today is the second day of our SQL focus, so we'll be focusing on data modeling with SQL. Show of hands, who was here last week? Okay, most people. Great. If you were not here last week, please get set up with Hex. I'm going to go through that real quick. Here also. Perfect. Okay. So if you were here for any of the Excel session, this will be kind of a similar format. So we're going to be doing a lot of interactive exercises as we go. This is not just going to be me lecturing. You do want to get signed up with a Hex account. Hex is the tool that we're going to be using to write both our SQL queries as well as our Python code in the upcoming weeks. So what you should do if you were here last week, you just log into that it's the same site, app.hex, and you'll see that you're logged in. If you haven't done this yet, go to app.hex.tech. That's the website. Make sure you sign in with your USC email address. And when you do that, you'll get a pop-up that you can join the Annenberg Digital Lounge workspace. And that's where our kind of little template thing for today is going to be. So make sure you go to this site. If you were here last week, you should just log in and you should see kind of the stuff you were working on last week. If you weren't here, make sure you do this so that you get logged in. And once you're in our Digital Lounge workspace, you should see a fall 2024 week 2 option. It's going to look like this. All right, so this will be our little template that we're going to use for today. That's got the exercises that we're going to run through. All right, so once you're in there, go ahead and find this. You're going to want to hover on the ... So just click on the name, go on the ... Okay, and then you're going to duplicate, and that'll make a copy for you. That'll sort of be like your own personal copy of our worksheet for today. So I want to give everyone a moment to do this because you're not going to be able to kind of follow along with the queries unless we get this part sorted out. So this is sort of part 1. Make sure you see this Annenberg Digital Lounge thing if it's your first time logging in, and click on that. Once you're in there, you should look for this and duplicate your own copy. All right, and if you run into any issues, you can't find the button, you can't find this, give me a wave and I'll come help you out. Okay, I'm going to give everybody a moment to do that to make sure we're set up before we get into it. Can I get a little wave if anyone's got it successfully made your little copy? Okay, got a couple thumbs up. Give people one more moment. Hands up. Okay, if you just go back to the Hex logo in the top, it just popped into like a weird template, and then there's week 2, and if you hover and do the ... you should be able to make a copy. Duplicate? Yes, duplicate, yes, okay. Great. Yeah, if you log in and you get like a welcome to Hex thing and you don't see this, hit the logo in the upper left, and then you should see this in the list. Anyone having issues or not finding? Yeah. No. Okay, so do the logo in the upper left. Great, and then there's week 2 if you hover, and then do the ... This one? Yep, hover, yep, and then duplicate. Perfect. Anybody else? That's a little confusing the first time you're in there. Okay, I'm gonna assume everybody's good, but if we get to one of the exercises and you realize that it's not working, give me a wave. This is intended to be interactive, so I wanna make sure that's working for everybody. Okay, that for the housekeeping out of the way. Okay, let's talk about how this fits into our overall workshop. So this fall, the purpose of this series is to teach you all some kind of intro to data analytics skills using 2 of the most common tools in this space. The first and my personal favorite of these is SQL. Another extremely common and useful one is Python. And so the way that this is set up, last week, for those of you who were here, we did a little intro to SQL. Today, we're sort of doing like SQL 201, if you will. So sort of diving in deeper to SQL and talking about some of the functionalities that it's used for most commonly, which is data modeling. So we'll get into that in a second. The next 2 weeks, we're not going to be doing any SQL. We're going to be, well, very little. We're going to primarily be doing Python for the next 2 weeks. So it'll be a little bit of a gear shift, but all building towards, in our last week, we're actually going to bring those two together and sort of do a little practice project using both of these programming tools. So encourage you to come for the next couple weeks as well. They're both good sort of things to have in your tool belt. And then in the last week, we'll kind of put them together and do some cool visualization stuff as well. All right, this is just kind of how that fits into our overall agenda. So what we're going to do today, we're going to start with a very quick review of everything that we talked about last week. So if you were not here, it should just be like a quick little run through. Hopefully you've seen a tiny bit of SQL if you weren't here last week, just so you know where you're starting from. But we'll run through that. We're going to talk about data modeling as our primary topic today. Two of our kind of supporting topics for that are going to be joining data frames together. So if you remember at the end of our session last week, we started practicing joining data frames together. That's a complicated idea. There's a lot of ways to do it, and it underlies a lot of what you'll do with SQL as you move forward in your learning. So that's going to be our focus today, is getting you all a few times through of practicing joining data frames together, understanding how that works, debugging them, and making sure you can do that comfortably. If we have time, which I think we will, we'll talk about casting data for data types, which I'll explain more when we get there. Okay, so I'm going to dive right into a little bit of SQL review. So as a reminder, any kind of SQL query you write is going to look like some subset of this. Almost all queries are going to have a select and a from. So you're going to tell SQL which columns you want from which table. And many queries that you write will also have some of these other components to them. Join is a big one we're going to be talking about today. Where is going to be where you add your filtering conditions. Group and order by are going to be kind of some of the tools we use to clean up and organize our data. And then we're also occasionally going to be using limit, which is just giving you a quick taste of your results if you only want a certain number. All right, if you're just coming in, make sure you hop into our Hex workspace and make a copy of the week 2 template. All right. Okay, so just a reminder of the types of queries that we talked about last week. These are some of the typical queries you'll find yourself writing over and over and over again if you're doing any sort of work with SQL. I write queries like this probably multiple times a day at my day job. So the first is just selecting everything from a table. Select star is our shortcut for selecting everything. Limit is just saying we just want to see the first 20 rows. You're often going to write a query like this anytime you are using a new data table, just to kind of get a sense. It's the same thing as sort of popping open the Excel sheet and just see what your data even looks like before you start manipulating it. We'll be writing some of those today, in fact. All right, this is another example, sort of the slightly more complicated query that we wrote after that one. This is bringing together a couple of ideas. First of all, we're grouping our data by one of our columns. So in this case, we're selecting the characters. We are grouping by those characters. So we were looking at TV data last week. And then we were using our count function to count from our transcripts data set, which was one row for each line of dialogue. We're using count star as to rename our column number of lines so that we end up with a data table that has many fewer rows than our first data table that we started with. Right, this is just going to have one row for each character and then a column for how many lines of dialogue they had. So this is one of the ways that we start kind of manipulating our data together. And this also has an order by. Order by is how we're going to sort our data. It's the same thing as sort in Excel or Google Sheets. We tell it which column that we want to sort by. And in this case, we wanted to know who's going to be talking the most. So we said sort descending, so sort reverse order. All right. One more kind of reminder of what we talked about last week. We started to get into formulas. We'll get some more practice with these today as well. So similar here, we have a group by, so we're grouping by 2 columns, in this case, season and episode number. And then we're adding a few formulas. Count is that one that we saw on our last screen, so lines of dialogue. This is what we just talked about. We've added, though, a more complicated formula here, which is our case formula. All right, so what our case formula is doing is taking a when condition. So this is very similar to our where condition that we had in the previous. So when a certain condition is true, so when a number is greater than something, or when this text is equal to this text, something like that, then grab this column or this formula of a column and give it this name, Elaine lines. All right, so what this one is doing is saying, all right, for every season and every episode, we're going to count first all the lines of dialogue. Then we're going to have another column in our final data set that's going to just count the number of times that our character Elaine had a line of dialogue. All right, so you could imagine if there's 500 lines of dialogue in an episode. Actually, I don't know if that's a lot. I don't know how many lines of dialogue. Let's say there's 500 lines of dialogue in an episode. Let's say Elaine talks 55 of those times. We'd have a row that would say season 1, episode 1, 500 lines, 55 for Elaine. All right, so this is, we're going to be building on a bunch of this today. And then the thing that we talked about right at the end of our session last week is joining data frames together. So we're going to get a lot more into this today. This is the join that we did last week. So last week we created 2 data frames with other queries. One query that we did made a data frame that had each episode with that episode's ratings. All right. And then our other data frame had each episode with the number of lines of dialogue. All right. So we have 2 tables about our episodes with different pieces of information. They both had an episode number. So what we did is we joined those 2 together using our season and episode number columns, because those columns existed in both of our data tables. So we essentially ended up with one big table that had all of these columns plus these 3 columns that we've added on. Okay, so that's the basic piece of joining that we talked about right at the end last. All right. I know that was a lot. If you weren't here last week, I wanted to just give you a quick orientation to getting around HEX, which is our tool for today. So if you're in HEX, you should have made a copy of this fall 2024 week 2 data modeling template. If you didn't, we're going to go to an exercise in a second. Give me a little wave and I'll come help you get it set up. So a couple things you should know about HEX. On this left-hand sidebar, this will probably be collapsed for you. The third icon down looks like a little stack of Oreo cookies. This one is going to show you all of the different data tables that we have in there to start with. So I've preloaded a few data sets in there for us to start with today. You can go into here and see what are our tables, how many rows do they have, and what columns are in them. So our project for today is going to be looking at data from the Paris Olympics. All right, so this is a data table that has a row for every athlete, for example. So you can see what country they're from, their height, their weight, what events they were in, et cetera. That all makes sense as athlete data. Okay, so remember, you can always get to your data frame. This is a good way to remember what your column names are that you're trying to access. And then what you're going to be doing in between each task, make sure you're in notebook mode up at the top. Notebook mode is going to have some SQL cells, kind of empty ones already in here for you. Just to show you what this looks like, right? So we're about to do this task number 1. There's an empty SQL cell right here. So you can just type on in there to type your SQL. Once you have something typed, you can hit Command Enter on your keyboard or just run. And then this, or you can hit this little run button if you like. And then anywhere in this whole document, you can add more SQL cells. So you can just hover in between any cells, you hit add and just make sure you grab the one that says SQL. Okay. All right. So what we're going to do first, is there anything else I want to say about SQL? No. Okay. Great. So everybody should be, you should see at the top, it should say like copy of fall 2024 week 2. You should be in notebook mode right here. And then this is just going to be our little bit of intro. So quick word about this before we dive in. As I mentioned, our data, this is actual real data from the 2024 Paris Olympics. So hopefully this will be kind of fun to look at. There is a tiny bit of Python code here that we're not going to talk about today. We're just going to run it because it's just going to load up our data and let us get to our SQL. We will talk about what this Python code is doing next week. So all you need to do on this cell right here at the top that says code to import pandas, this thing, all you need to do is hit the little run button. It's a little play icon on this cell. Make sure you click that once. It'll think for a second and you'll see these little green table names pop up underneath. That just means that those are the tables that are available to you to query. All right, once you have those tables, you'll be able to find them in your data browser. So that's what I mentioned just before. If you look in your left sidebar, under data browser, data frames, you'll see athletes data, medalist data, etc. You'll see your little tables. Okay. Right. All right, so make sure you do that. This is just a little quick reference of one of the slides I just talked about. So we are just going to warm up with some super simple quick queries. Task number one, we're just going to write a query to get the first 10 rows of the athletes data set. Do the same for the medalists data set. All right, so as a reminder, this is the kind of query that we talked about right here. This is the same as the first query we worked on last week. So you're going to write something like this. Select everything from whatever the name of your table is and grab the first 10 or 20 rows so you can take a look at that. All right. So I'll do this first one along with you. And that's an example. I'm going to type into my SQL cell something like select star from. I go in my data browser and look at my tables. I see I've got an athlete's data. I'm going to type in that. All right, but I just want to see 10 rows because it looks like there's 10,000. Once I've got something like that typed in, I'm going to hit Command Enter on my keyboard, and that's going to run my query. If it's successful, I'm going to see my little data table just below, and I can scroll on through, see all my results. If something went wrong, I might get an error message right here, in which case either give it a read, and if you can't figure out what it's saying, give me a little wave and I'll come help you out. All right, so you should be grabbing the first few rows of our athletes table, our medalist table, just to get a sense of what the data looks like. Yes, push me. Oh, okay, that's going to be in data frames. Okay. Yeah, you got it. Yeah, in your left sidebar, the first time you go to it, you're going to click data frames so you can see this list. All right, so once you've got your athletes data, you can add another SQL cell. So remember, that's just hovering in between any existing cells. You can add another one and do the same for the medalists data. All right. Anyone having any hex errors? Everybody is able to type in their own copy. Just going to need that. All right, give me a quick little wave if you're able to find the first 10 rows of our medalists data. Seeing a couple head nods. Okay, great. If you're not there yet, that's okay. I'm going to do a little demo along with, so I'm just adding another SQL cell down here. It says type some SQL. I'm going to look in my data browser to find out what that medalist data table is called. Looks like it's medalists data. All right, so I'm going to go over here and type in a very similar query. I'm going to do select. So all my statements start with star for everything. And then from my table name, which in this case is my medalist data. And actually, as I start to type, I'm going to see it's going to recognize that I've just typed from. I'm probably about to type a table name. So it's going to give me some little handy autocomplete. All right, once I've got that in there, I either need to click my little play run button on the upper right of this cell. I personally like to just do Command Enter. And I get my metal data. I just want to kind of take a quick scroll through and get a sense of what's in here. What does this look like? Which columns are filled in, which columns are empty, etc. Okay. All right. So this is the typical kind of query you're going to write anytime you start working with a new data table. You're just going to make sure there's some data in it, kind of see what the data looks like. The other thing I usually do when I start with a new table is the second part of this task, which is to get the number of rows in these two data sets. Now, since we're using this cool tool Hex, if you already have your little data browser open, you'll notice that it already tells you this answer. It already tells you that our MetaList data has 2,315 rows. That's super snazzy and cool. If you didn't have this data frame thing open and maybe you didn't see that, or you're using a different SQL tool that doesn't have the little built-in capabilities, you can also grab this from a simple formula. So I could do something like select count star, and then from that same table I was just looking at up here, which is my MetaLists data. All right, so from MetaLists, it's gonna give me the little autocomplete because I've just typed from. And then when I run that, I'm gonna get just one row, one column, one tiny result right here, 2,315, which matches what I saw in my data browser. So that is all good. All right. Everybody's Hex working okay, able to add cells, write a few initial queries. If anything's not working at this stage, definitely let me know because I want you to be able to do the rest. Great. Don't be shy about giving me a wave. Okay. So just to get us a little bit warmed up, I'm going to talk about a couple other things before we get to our next task. All right. I will just say, I guess, one last thing, which is from your Hex sort of view here, we're primarily going to be a notebook view because we are typing. If you toggle over to the app view at the top, you see sort of like a little bit of like a cleaner view. This is just sort of the cells that have been selected to sort of be in the final product. Since this is just our worksheet for today, we're not super worried about making this like a clean final report, but you can toggle back and forth if it's easier to read little task prompts on this one. It's totally cool. All right. All right. So before we get to task 2, which is going to be sort of the start of our data modeling adventure, I want to talk a little bit about what is data modeling. So data modeling is a practice that's very common in any sort of data analytics that you're going to do, any sort of analysis, especially any sort of analysis that you want to repeat. You may have been in the situation with a class project or an internship or something like that, where maybe you did something with a spreadsheet, you had a bunch of spreadsheet data, you did a bunch of manipulations, you got a final result, and then you needed to like do it again the next week or the next month, or you needed to add some more data and sort of reproduce the report. And it can be hard to remember all the little changes that you made, like, oh, I corrected the spelling on this, one category name, or I changed this column name because it didn't match this other table. There's a bunch of stuff you do that can be hard to keep track of for sort of repeatable, reproducible analysis. And so what data modeling essentially allows you to do is write a set of SQL queries that do what you need to do with your data frames. And then if you have, say, an updated set of data or additional data that you want to add in later, you just run those tables through the same queries that you've already written to make sure that your analysis comes out the same way. You don't accidentally skip a step that you did, maybe weeks or months ago and can't remember. The other benefit of data modeling is that once you write that set of queries, the end result is a table of data that's much cleaner and much easier for other people. Typically, we call these like business users or sort of folks who are maybe a little less tech savvy or less data savvy than you, a little bit more straightforward, kind of cleaned up view of the data that they can use more easily. All right, so usually what you're going to be doing is getting some initial data sets from, we call the source data. This could be from a database. In this case, this was from some website affiliated with the Olympics. I downloaded all of their kind of official Olympic data. And they all come from a bunch of different systems, so they're not super clean. Like in some of our data files, the athlete is only referred to with their ID code, not their name, right? So there's stuff like that where as an end user, I would probably want to know that athlete's name. But some of what we're going to do in data modeling is make those connections, all right? So basically what you're going to be doing to get to your completed data models is starting from your source data and writing SQL queries that typically do some joins, some formulas to get the data to a place that it would answer kind of common questions for an end user. That's a little bit sort of about theoretically what is data modeling. Let's talk about an example of data modeling. Okay. So in this example, these are three data tables. Each square is a data table or a data frame. These three on the left are our source data. Okay, so you could imagine, say this was the USC Central Student Information System. These are tables that exist there. So systems often have tables like this. We may have one about students that would have, say, your student ID number, first name, last name, probably a bunch of other stuff, your address, your birthday, all kinds of other stuff. Okay, but one row per student. Then you could imagine we have a table of enrollments that say, all right, for this course, this student is enrolled in this semester and they got this grade. All right, so this course, which this isn't a real course, but if it were, this course has, say, 20 people in it. There'd be 20 rows that have, course ID is SQL week 2, and the student ID is each of your student IDs, the semester date, and then obviously I'm not grading this class, but you would have the grade assigned to that class. All right, and then probably somewhere else in the university system at like the registrar or something, there's a table that tells you what letter grade corresponds to what numerical grade. Okay, so an A is a 94 and an A minus is a 91, right? Whatever those numbers are, right? Somewhere in the world is that table. And what is a typical end user wants to know about students is their GPA. So we have all the components to get to a GPA here, but we actually have to do quite a bit of manipulation to get to that. Now, you could say, all right, well, just if I need the GPA, I'll just like write all the queries to get to the GPA. Fine. And you could do that, except a lot of people at the university are going to be looking at this data are going to want the GPA. That's like a common thing to ask for. That's a concept that exists in our minds, but doesn't exist in our source data. So what we're going to do is data modeling, which is write a few SQL queries that get to the GPA. And so that every semester when new students enroll, we just rerun that query and then we have a list, self-updating list of all the students and their GPAs. So the way that we would get from our source data to our kind of student GPA table is we're going to do a couple of joins. So the first thing that we're going to do is we're going to join together our enrollment and our letter grade kind of registrar table. The reason to do that is there's a column here that has a letter grade for each student, but we need to know the number because you can't average together A, B, C, D, right? So you're going to join letter grade onto letter grade here. So you'll notice enrollment 2 is the same as enrollment. It just has this additional column, right? We have 4 columns here. We're going to have a 5th column here that's numerical grade. And all we're doing is we're saying, okay, we're going to look at every letter grade in enrollment. We're going to find the corresponding one from the registrar, and we're going to stick it in a new column. All right, so that's like part 1 of our data model, step 1 of our data modeling. Okay, step 2 of our data modeling is now we have this for every course for every student. We only care about GPA per student. So the next thing we're going to do is take this chunk of data and summarize it by student. All right, so we have the numerical grade for all the courses they took. We have the student ID. So we're essentially going to say, select student ID, select average of numerical grade, and come out with a student summary. We could also count how many courses they took, etc. So this is what we want. We have student ID and grade point average essentially here. Great, we could totally end there. Except this does not have student name. And most people who are going to be looking for GPA information are going to care what the student's name is. They might be searching by name, they might be filtering by name, etc. So the last step we're going to do is we're going to take this data, which now has one row per student with just a couple pieces of information about their grades. And we're going to join it onto our initial data set of our students, which has their name and address and birthday and all that stuff. So once we join these two tables together, that's what this big wiggly arrow is doing. That gets us to our final data set, which basically just has all the information from one of our source tables, plus some summarized information from our other source tables added on. So it has this new column, grade point average. Okay, so that sort of makes sense, kind of like how we get from sources to our final data model. And it, like, rough idea makes sense. Okay. All right. So that's what data modeling is. Let's talk a little bit more about why we do data modeling. This is a common joke on the internet forums for anybody who does data analytics, but often you get a request, oh, can you just quickly pull this data together? Can you just quickly grab all the student GPAs? It's a common thing. But if you haven't done any data modeling and you're just starting with those three tables that I talked about, you can't just write a quick query that's like, select star from student GPAs. That table doesn't exist yet. Nobody's done the data modeling work. So what you would have to do is write these three joins, make sure they're all working, make sure that like the final data makes sense. And that's hard when someone's just like, can you write me a quick query and get me this for this meeting in 5 minutes? So that's why we do data modeling. We do data modeling so that any sort of thing you might need to reproduce is ready to go. And also, as sort of an analytics person, you might be your own end user in that when you're creating a dashboard chart, a visualization, say, of, you know, what's the average student GPA by major, for example, it would be much easier if you already had your student GPA table and you could just group by major and be done, versus if you had to redo all your own steps every time. So you can sort of think of yourself as the end user as well. Right. So that was sort of like big picture, what and why are we talking about data modeling? We're going to get a little bit more nitty gritty now into like, what does that actually mean in your SQL query? So the most common thing that we're doing in data modeling is joining. There are a bunch of types of joins, but these are the two kind of most common ones used. So these are the two that we're going to talk about today. The first one is just join, which I will just call regular join. So that means that you're going to bring all the rows from two data frames together as long as they have matching values. So any student that's in our kind of, registrar database, and any student who's in our GPA table, we're going to look for a student ID number. And as long as that student ID number appears in both places, they'll have a row in our final table. Now that means, let's say a student signed up to come to USC, but maybe had to withdraw. They ended up not being able to take any classes, so they don't have a row in our GPA table. If we're going to use a regular join, that student gets dropped. That student's not going to show up in our final table because a regular join is going to look for a match in both places. Now, if we want to avoid that, if we say, well, we care about all these students and we just want to get anyone who has a GPA, we can do the other most common type of join, which is a left join. Left join is saying, imagine your data frames are next to each other. So it's like table 1, join table 2. What left join is going to say is no matter what, keep everybody from table 1 in our final result. Now, if any of them also appear in table 2, tack that information on. So in this case, our student who maybe signed up but never ended up enrolling in any classes, if we do a left join, that student's going to show up in our final GPA data model. Their GPA is going to be blank because that student wasn't in our GPA table. They're not going to, like, there is no GPA to grab for them, so that value will be blank, but the row for that student will still be there. All right, that's sort of the conceptual difference between these two types of joins. So you could imagine there's different cases where you might want to do that. For example, if you wanted to calculate the average GPA by major, you might want to do a regular join because you wouldn't want to include a student who withdrew before they took any classes. That would sort of average in an extra 0. That would bring the average GPA down. That maybe isn't what you want to do for the purpose of your, dashboard or whatever. Okay, any questions about a regular join versus a left join? Will also make more sense once we start doing it. Okay. Cool. A little bit more talking for me, and then we're gonna put this into practice. So here is sort of the kind of mental model you can follow for constructing a query with a join. So you're gonna start like you pretty much always do with a select some columns from a table. All right, that's how you should start writing pretty much any query. But you should be thinking when you're gonna be joining, which tables am I gonna need? Specifically, if I'm gonna do a left join, I should start with that main table where I want all the rows. Okay. You also want to make sure that each table has one row per entity, if you will. So what that means, if we go back to our student example, I can't just join this enrollment model onto our student model because a student probably takes, what, 10 classes a year, maybe 40 classes in their whole degree. This table has 40 rows per student, and this table has one. So if we try to join, we're trying to join 40 things onto one thing. That doesn't really work. We'd have to like pick one. That doesn't really make sense. So what we did is we summarized this down to have many fewer rows. So it just has one row per student. So one row per student, one row per student. Those are good candidates to join together. So we just join on that student ID. All right, so that's what I'm talking about here when I'm saying one row per entity. All right, if you're trying to get to data about students, you need to make sure that your data set is about students on each side. And if it's not, you might need to do some summarizing first. So that's the summarizing step that we did right here. We're just grouping by student ID to get our summary down to student level. All right, so you're gonna make sure your data is all summarized. You're gonna think about this left or right join, or this left join or regular join issue, which is, do you only want rows that show up in both? Or do you need all the rows from one table and you're just sort of augmenting information? That'll tell you if you're going to use join or left join. All right. And then for all of the tables that you need, how are you going to join them? So there's two ways that you can join them, depending on what the column name is of that unique identifier. So let's say, for example, you have two data sets that both have people's email addresses. All right, this is like a common like unique identifier you could use. If you have your two data sets and they both have a column called email, you can just say using parentheses email close parentheses. It's going to look for a column with that name in both data sets, and it's going to join them together. Now, let's say you have your two data sets and you're going to join on email, but in your one data set, the column is called email, and in your other data set is called email address. Okay, the column name is slightly different. Then you can do the exact same thing, but instead of using, you're just going to tell it on, and you're going to give it those two column names equal to each other. So you're going to say on email equals email address. All right, just in case your data is coming with different column names. All right, so you're going to look for those column names. And then the very last thing you're going to do is think about what columns do you want to end up with. All right, so this is typically where you're going to be adding sort of a comma after whatever columns you initially grabbed, and you're going to be probably putting in some formulas. Okay, so this is basically what we did here, where we said, all right, here's our student ID. We're going to do some formulas, right? We're going to count the number of courses they were enrolled in. We're going to average out their grade, and we're going to join it together with their kind of student demographic information. All right. So I will come back to this later, but this is sort of like the mental path you can think of as you're constructing your query. All right. Cool. One other component I'm going to talk about before we get back to practicing writing some joins. So we haven't talked a ton about the where part of a query. The where part of your query is where you're applying filters. So if you were using like a website with a dropdown, say you're shopping for something and you want to filter for only pants or only tops on the shopping website, that's what you're doing with a where condition. So there's a few different ways you can filter depending on what type of data it is. If it's data that's a number, so for example, last session we were working with data about seasons and episodes of a TV show. So, season 1, for example, we could filter for season equals 1, or season does not equal 4, or season greater than 6, right? We can use sort of all our basic kind of numerical comparison tools to filter any column that's a number. So some quick things to note, if you want to do not equal to is exclamation point equals sign. And then greater than or less than, you can also do less than or equal to by just adding on another equal sign right afterwards. All right, so those are some of the tools we can use to filter if our data is a number. If our data is a string or a piece of text, then in our where clause, we have some slightly different options that we can use to filter. The first two are the same, right? So equals, this is a very common one. Maybe if you want to filter down by if their major equals journalism, for example, you would do equal quote journalism, close quote, and that would be your filter. Or same thing if you wanted to say not equal. And then we have a few other options for text. You can also say, I just want it to be one of these majors. I want to filter for people who are either journalism or communication management, say. Then you can give it a little list. You can say, I want where this, where major in, and I do my parentheses, and I do a little list, in journalism, comma, communication management, comma, anything else I wanted to add. All right, so for text, I could do one of many. And then our last two options for text are pretty fun and pretty commonly used. One is like, and one is I like. I like just means case insensitive. Okay, so if you're trying to filter and your data might be a little messy, maybe some people capitalized journalism when they typed in their majors, some people did not. You can use I like to say, I want to get anyone who has this phrase in any capitalization in this piece of text. And the last piece that is very commonly used with this is you add some percent symbols before and after that phrase. That means if that phrase appears anywhere in that chunk of text. So I think in the historical data for Annenberg, they used to have print journalism and digital journalism as separate majors, maybe radio, right, like separate types. So I could say, I want major, I like journalism. And if I include these percents, it'll get any subtype of journalism that was previously a major, right? It'll get print journalism included because this phrase, the percent signs are telling it just match anywhere in the text as long as you find journalism. Okay, I know I just threw a lot of information at you. We're gonna go back to an exercise now to kind of put all this into practice, try writing a query with a join and a where clause. All right, so if you want to hop back over to your Hex doc, we are going to move down from task number 1 to task number 2. All right. The question that we want to answer is what percentage of rowers who competed at the Olympics received a medal? Okay. So just breaking down this question a little bit. We have rowers at the Olympics. So those are going to be in our athletes data table, right? Anyone competing at the Olympics will be in our athletes data table. And then anyone who received a medal will be in our medalists data table. So we notice our medalist data table is way smaller than the total number of athletes who competed, because obviously not every athlete gets a medal. That would not even be fun to watch, right? We're watching to see who gets medals. So we need information from our athletes table. We need information from our medalist table. And we want to filter down to only get people who are competing in rowing events. All right. So we're going to need a join to combine our athletes and our medalist table. And we're going to need a where to do our filter down by their sport involves rowing. Okay, so to answer this question, you've got your SQL cell. What I would encourage you to do anytime we write a query is to start with a very simple query and see if it runs, and then kind of add pieces on. So if we know we want some information from our athletes table or a medalist table, you could start with a very simple select from statement for one of those tables. Okay, I'm going to put this back up, which is sort of our mental model for running through a query like this. So We want to know what percentage of rowers at the Olympics earned a medal or won a medal, received a medal, won a medal probably. Okay, let's go with won a medal. All right, so we want to think about which tables those are, our athletes data and our medalists data. All right, does each table have one row per entity? I think probably for this case, we could assume that they do, but perhaps they don't. So we could think about that. Next thing is, do you only need rows that appear in both tables or all rows? If we want to get the percentage of rowers who earned a medal, if we join our tables together using a regular join, we're only going to get rowers that appear in our medalist table. We're not going to get anybody who did not earn a medal. So since we want to get percentage, which includes, meaning we want to understand of the total who got a medal, we're probably going to need to use a left join because we don't want to drop anyone who didn't get a medal. So otherwise, how are we going to calculate our percent? Okay. All right, next thing to think about is how will we join our tables together? What piece of information connects our medalist table to our athletes data table? So you could figure that out in a couple ways. You could go back up to the previous task where we looked at a few rows of athletes and medalists, and you can look through the columns and kind of see sometimes it's just easiest to do it visually. Is there an obvious sort of unique identifier? Is there an email address, an ID number, something like that that connects our two sources? And what is that column name in both of our, is it the same column name? Is it a different label in one of our tables? So that'll tell us if we want to use using or on. And then the last thing we want to think about is what formulas or what columns do we want to end up with, and what formulas do we need to end up with those columns. I'm gonna give everyone a minute to sort of start wrapping your head around that, and then we'll sort of walk through what that looks like together, okay? Right. People kind of starting to put together pieces of their query. All right. So going back to what kind of our steps for joining our data sets, we want to figure out what columns we want to end up with. Okay, are we going to need any formulas? So here are the columns that I ended up with in my sample. So I ended up with a column that had the count of all the rowers. I had a column that counts just the rowers who won medals. And then I have a percent where I'm just doing this division. So I can get my percent of the rowers that earned medals of all my rowers. All right. So hopefully you started a little bit with grabbing some data from the medalist table, from the athletes table. If you didn't get the whole join working yet, that's okay. We're going to go through it together. Okay. So there's a few different ways to do this. That's going to be true of all the queries that we write today. There's a few different ways to do them. They get to the same result. Okay. So if you got the right result or you got close, but yours looks a little different, that's totally fine. I'm going to walk you through one way that we could do this, and I'm going to kind of deconstruct it. So here is what I had. Let me kind of walk through how I got to this. So first thing I'm going to do is say, I know I need to select something from my athletes data. Okay, because when I think through our little checklist, I know that all my tables, one table is going to have all my rowers, one table is going to have just the ones who won medals, and I am going to need those ones who didn't win medals so I can figure out my percentage. So because of that, I'm anticipating I'm going to use a left join where I'm going to start with my athletes, and then for anyone who earned a medal, I'm going to kind of join that on. Okay. All right. So that's where I'm going to start from. Next thing that I'm going to think about is how to join my two tables together. So I just figured out, just from kind of thinking through the question, looking at my data, I think I'm going to need to do a left join with my medalists. I'm kind of constructing my query as I go here. So next thing I want to do is figure out which column I can use to bring these two data sets together. So to do that, I could either scroll back up and look at my select star from queries that we did in the first task, right? This is one of the reasons that you do this. So it looks like I have a name in here. I have a URL, but that doesn't really look like it's specific to each person. I have a birthday. In some cases that could work as an identifier, but some people might have the same birthday. And then I have code athlete. Okay, that looks like my most promising column in my medal data to figure out how I'm going to join onto my athletes data. Now, it might be the case that I could also use name. We can go look at that. Let's see. I'm going to go look at my athletes data now. I'm just going to look at this one in my data browser. So let's see, I have a column for code. I bet that's the same as athlete code over here, code athlete. I can scroll back up to where I checked before. Yeah, it looks like this is roughly like a 7-digit number from our athletes data. And if I go down and look here, these look like, yeah, those look like those are 7-digit numbers. So either from the column headers or just from kind of looking at it, you can usually figure out what it might be. Now, in this case, we also have a column called name in both of our data sets, which is great. So we could use name as a thing to join on as well, because we have name in both. As a general practice, I would recommend if you have a choice between something like name and something like ID or email, I would recommend that you choose the ID or email, only because people typically only have one ID number or email, and they might go by, John or Jack or Jacqueline or Jackie, things like that. Names can just be a little trickier depending on where the data came from. So in this case, there's two options for joining our tables together. We could use name or we could use this athlete code. I'm going to choose to use this athlete code. So I'm going to go look at those column names in my athletes table. The column's just called code. In my medalist table, it is called code athlete. I already lost it. Code _ athlete. So to do my join then, if I'm running through my checklist, since they don't have the same column title, I can't do join using. I'm going to do join on, and I'm going to give it those two column titles. All right. So what I'm going to do over here is keep building on my query that I'm writing. I'm going to say, all right. And then on code equals code athlete. And if I wanted to at this point, I could just say, all right, select star from this. I'm just going to run that and just see if that runs. Let's just see if my join even works before I worry about any sort of like formula or anything like that. Okay, this is looking pretty good. Now, we can see we have a bunch of rows. Hex is going to be helpful and tell us roughly how many rows this is going to spit out. And if I look at my athletes data, it also has 11,000 rows. So I know that my left join worked because I still have 11,000 rows. It didn't filter it down to just my medalist data because I did a left join instead of a regular join. Okay, so I still have all these people who didn't earn medals. All right, so now I'm going to add on a couple more things. First thing that I want to do is filter down a little bit more because my question was only about rowers. So I don't necessarily care about anyone in any other event. All right, so how would I figure out who is a rower? If I look at my athletes data, let's go back up. This is why I always do select a few rows at the beginning. Let's see if we can find how we figure out what sport a person is in. All right, so just from scrolling over and taking a look at disciplines, it looks like disciplines is what's going to store their sport. So whether it's wrestling or triathlon, and then there's a different column that gets a little more specific about sort of the particular Olympic event they were in. All right, but I can see that my disciplines have kind of a whole bunch of options. This is just from 10 rows. There's already a few different things. So I can see that that is probably where rowing is going to be. So I can do two things here. One is I can just hope it's under rowing and just type that in and see if that works. I could also select that whole column and kind of scroll through and see exactly how it's labeled in case it's spelled differently or called something else. In this case, I'm just going to say I'm hoping that it's rowing. All right, so I'm going to add my where because I want to filter this down for my 11,000 rows. That column I was looking at was called disciplines. So I'm going to do that column as my where filter. And then I'm going to use my text where condition that we were just talking about here, this I like. All right, I just want to make sure that it's rowing. This is like doing kind of a filter to make sure if on one person it's like rowing is not capitalized or something like that. Anytime you're working with a big data set, in general, it's good to do this kind of more general match to make sure that you're going to get anybody that is relevant. So hop back over to my query. So I'm going to say I like. So this is instead of like an equals or something like that, I'm going to say I like. And if any string, I'm going to put it my single quotes. I'm going to type in rowing. And then just to be super safe, I'm going to put my percentage signs on either side of rowing, just in case in one row it has an extra space in front of it or something like that. All right, so this is the query I just had. I just added my where clause. I'm going to hit Command Enter to run my query. And then I see it went way down, right? It used to be 11,000 rows. Now it's 497. All right, so that sounds about right. That's, they row in a lot of boats. That seems like a reasonable number. It's something I want to check at each stage. Okay. All right, so I'm getting very close. I have sort of all the components that I need. I've done my join. And then the last thing I need to do with this join is think about what formulas I want to end up with. So do I need to do any grouping? Do I need to do any formulas? All right, so if I go back to this, all right, it looks like I have a row for every athlete. I'm going to scroll over to the right and look at all of my columns. All right, let's see. It looks like we've got these medal columns for a bunch of folks, and for many folks, these columns are empty. All right, that kind of makes sense to me because probably not all 500 people earned a medal. So I think first thing that I want to do is figure out how many total people I have, how many of them earned a medal, and then do the percentage, which is just that divided by the other. All right, so I'm going to do my count. Count star is going to count everything. So I'm going to call that all athletes, or all rowers in this case. All right, so that's one count that I want. I could even just pause here and go and grab that. Okay, looking pretty good. And the next thing that I want to look at is how many of those people earned a medal. So in my medalist data set, there's this column called is medalist. You can see the type here is bool, which just means like it's true, false. It's a Boolean, true, false. So that seems like an easy one to count. All right, so what I'm going to do is I'm going to bring back my case statement, which we talked about last week. So I'm going to do a count, but in this case, I'm only going to count a certain case. I'm going to count case when is medalist, because I want to just grab when that column is true. And then I want to count them, so I'll just count their code. And I'm going to call them medalist rowers. All right, so all I did here, this is the same case statement that we did last week. So it's case when, whatever condition, then whatever you're going to count. In this case, just some column that's filled in for everybody. And just to indicate that this little thing is over before my parentheses, and that will give me my medalists. All right, so if I run that, you see my little results updated right here, all rowers to my medalist rowers. All right, so I've got 2 counts. And then the very last thing that I need to do is get my percentage. So how would I get my percentage from here? I'm going to do some simple division. Okay, so I have 144 of the 497 rowers at the Olympics earned a medal. So I'm going to do that division. So I'm going to take my medalist rowers, which I just calculated right here. That's this column. And I'm going to divide it by my other column, which is my all rowers. Then I'm going to call it percent medalists, say something like that. All right, let's run that. And then you'll see it adds a column to my results. So now I have 3 columns in my results. I have all my rowers, my medalist rowers, and I have the percent that won a medal. All right, the very last thing that I would do on these results is my percent showed up as a decimal, right? As percentages often do. In hex, I can just change it to display as a percentage. So once you have your percent medalist column, you can just click on it right here. And in your little pop-up, you can change the format from number to percent. So I'm going to change the format to percent, get back out of this, and now it's got my 28%. Nice and easy. That's not so bad. If you go to the Olympics for rowing, there's like a third of a chance you leave with a medal. Pretty cool. All right. Okay. I realize that was a lot, but that's an example of how we combine kind of all the pieces that we've talked about before. We talked about joining, we talked about using a where condition, and we also used some formulas, a few different ones. We did count, we did case, we did some simple just arithmetic, and all of that created this nice handy data model that we have. All right. So any questions about this query before we continue on? Any questions about how this works? Did anyone get in here? Yeah.
How can I change my percentage medalist into the percent, because minus was a lot less.
Yeah, totally. So once you have your percent, you can click on it just in your results here, you can click on that header. You'll get this little kind of menu that pops up. In that menu, you can go to format and just grab a percent. So I think it defaults to number usually. Any other questions about this? Yeah.
Just wondering, the spaces between the asterisk, how much does it matter? Like, let's say you forget to put, or you put a space after count, like.
Yeah.
Well, what happens?
Let's try it. Let's put some spaces after count. Boom, great. Yeah, so to answer that question, in most places, an extra space, or you can even do an extra line. Like sometimes if I'm writing a long case statement, just so I can read it myself, I'll hit enter and tab a few times and move this over. So you can in general add a fair amount of spacing. Yeah.
So it's not gonna affect the whole solve them.
For the most part, yeah. I think there's a few situations where it might, I'm trying to think of one. If you put an extra enter or space between the equal sign, let's see if that does anything. That's fine. If I do a whole enter, does that still work? That still works. Yeah, so in general, it's not something to worry about. If you have a bunch of stuff spaced super weird and you're getting an error, it might be something to look at, but not super common.
But it is important to do it 1, 2, 3, to put the enter in every formula. We're also doing HTML, and it's just a preference of formatting, because you can do the whole prompt in one horizontal one. So it's Does that apply to this as well?
Yes, very good question. Yeah, so for this, it's totally up to you how you want to divide it on different lines. So I could write this entire query on one
Just
line if
one
I wanted to.
sentence.
Yeah, exactly. It's just hard to read.
Yeah.
Yeah, so typically the way you'll see a lot of queries written and the way that I like to write them is you'll kind of start with kind of your main keywords on the left and put those each on a fresh line, but you certainly don't have to. Yeah, great, good question.
Thank you.
Any other questions? All right, okay, so we are gonna dive into some more hands-on practice. Okay, so for this next one, it's pretty similar to the one that we just did. It's like slightly different, maybe slightly simpler even in some ways. So what I would like for you all to try next is to give this next one a try on your own. Okay, I want you to try to write this query yourself. It's gonna be pretty similar to what we wrote for this last one with a few differences. Okay, so the question for this one is for each sport discipline, what percentage of athletes earned medals? So we just did this for one sport. So for this, we're essentially going to figure this out, but not just for rowers, for each sport. Okay, and then once we have that, we can tell which sport has the lowest percentage of medal winners. Okay, so for rowing, it's 28%. For some sports, it's going to be higher and lower. Let's find out what sport has the lowest percentage of medal winners. All right, so I'm going to give everybody, let's see, we'll start with like 3 minutes. All right, so I want you to look at this question, look at this query that we wrote for the last question, and see if you can put together your own query. If you can't get to the final result, that's totally okay, but make sure you figure out what your join is, what your grouping is in this case, because we've got a bunch of disciplines this time. All right, there's a note up at the top of the sheet about all the different query parts. So you can look back at that. I will give you all 3 minutes and I'll check in. Get stuck, give me a little wave and I'll. All right, does anyone think they have a query? Everybody, one more minute. All right. We'll show of hands if you have like a partial query, even if it's not the total thing yet. A little like head nod or something. Okay, seen a couple head nods. All right. Okay, for each sport discipline, what percent of athletes earned medals? Somebody gave me a little nod. You wanna tell me what you got? Anybody? Is anybody getting an error message? Maybe let's try there. Are you getting an error message with something that you're running? We're just not quite full results yet. Where are we at? Maybe feeling a little stuck. All right. We can walk through it together. You're part of something? You wanna tell us what you got so far?
I got like error message.
Okay, all right. What you got? We'll figure it out. I mean, everybody's gonna run into the error message. We'll figure it out. What you got?
I think I have like couple of questions, not only one problem.
Okay. All right, so you've got select.
Select count star sign.
Count star.
As medal winners.
Medal winners. Okay.
Yes, and count.
Right, count.
I'm actually not sure like about like case when ending.
Okay, that's okay. So you tried to put a case here.
Yes.
All right. What were you trying to do with your case? All good.
I'm not sure.
That's okay. And so you were coming from the athletes
Yeah.
table? Okay, great. All right, from athletes data. All right, cool. So since this is a very similar query to the one we wrote before, I'm actually gonna see if I can use any pieces of this that I already used. So we started from our athletes data, but we joined on our medalist data before, right? We did this left join, we did this before. So I'm actually just gonna use this same left join. I'm gonna copy paste that on down to this same query here. All right. So I could start with count star from this. This is like very similar to how we started our other query, right? We've got our 11,000 athletes. We haven't filtered anything down. Now, if we go back up to our other query, we have this where discipline I like rowing. We don't actually need that filter for task 3 because we just want to look at all the disciplines. So I'm not going to copy paste down this where line because we're not going to filter down. Okay. All right. Let's take a look at our other columns that we had though. So we had count star as all rowers. back out onto a separate line. We had count is medalist as our medalist rowers. All right, and then we did our percent. So what I want for this is very similar. I just don't only want it for rowing. I want it for all the sports, right? So I need to know which sport it's for, but then I want it for each sport. Okay, so because this is very similar, I'm actually going to copy paste also this down to this query and kind of start from here. All right, so all I've done so far is I've copy pasted the whole thing except this where line, because I know I definitely don't need that because I'm not filtering by rowing anymore. Okay, so I started with just copy pasting. That's a great strategy. If you feel like you wrote a similar query before, copy paste that one and start tweaking it a little bit. Okay, so if we take a look at this, I'm going to relabel, first of all, my columns because I don't want them to be about rowers. So I'm going to change this to all athletes. I'm going to change this to medalist athletes. Same here in my little percentage. I'm going to just retitle my column. So all I did is I just changed it from all rowers to all athletes, just because conceptually I'm not doing just rowers anymore. And actually, even though I just made that little change, I'm just going to run it again to see where we're at. Okay, so this is actually getting us pretty close to where we want to go because we haven't yet split it out by each sport, but we have the total number of athletes. We have our medalist athletes, so everybody who earned a medal, and then we have the percentage. So it looks like about 2,000 of 10,000, so about 20% are earning medals overall. Okay. So the last thing I need to do is be able to split this out by each discipline. So I essentially want a row for each sport. Does anyone have any ideas on how I might do that? How would I get this with a row for each sport? Anyone remember which column had the sport name in it from our previous query? Which column that was? Disciplines. Great. All right. I want to have a column for disciplines in my query. Stable. I had the same query I had before. I just added the column disciplines, which is going to come from my athletes data. All right, very cool. Let's run that. And we're going to get an error message. All right, let's read our error message. This query cannot be executed, receive the following error. All right, the important part of the error is always right here, this exception. Column disciplines must appear in the group by clause. Anyone have any suggestions on how to resolve this error? What should I add to my query to resolve this error? I don't need a where in this query, but I do need a group by. Yes. All right. So I'm going to add a group by, and I want to add by disciplines, group by disciplines. All right. Let's run that. Let's see how that looks. Okay, great. So this is the same three columns that we had before, and we just had the one row. But now we've added a column for the disciplines and we've grouped by that column, meaning it's just going to count up all the athletes that fall into each group, all the medalists that fall into each group, and the percentage for each group. All right, pretty cool. I'm going to change this, same thing, our percent medalist column. I'm just going to click on it. I'm going to click on format and I'm going to change it to percent. All right, cool. Click back out of that. All right, and then the last thing that I wanted to do is I wanted to find what sport has the lowest percentage of medal winners. All right, so it looks like these sports are all 20-ish%. All right, a couple of them are a little lower. Sailing is 12%. All right, but I want to find the lowest one. Does anyone remember how I might sort my results in my query? What would I add to my query to sort my results? perhaps put them in an order. Order by, fantastic. So after my group by, I'm gonna add my order by, but in this case, I don't wanna order them by discipline. That would just sort these alphabetically, okay? Sort them by percent, very good. So I'm gonna sort by percent. Our medalists, I can spell that, medalists. All right, great, we'll run that again, and it's gonna give me my same 52 rows that it gave me before, but it's gonna give me each discipline sorted by the percent that earn medals. Okay, now here we run into an extremely common data issue. So we see that in equestrian, there was one athlete and none of them earned any medals. In athletics, whatever that is, there are two athletes, none of them won medals, so those are 0%. Now that doesn't like mentally sound right to me that there would be an Olympic event with only one athlete. That like doesn't really sound right, so I'm gonna keep going. We'll look at cycling. This one had 175 and only 8 of them win a medal. So if you go to the Olympics for road cycling, there's like a less than 5% chance you come home with a medal. That's crazy. All right, but then we see it kind of keeps going up. So it looks like most events have like at least 30 or 40 athletes, if not more. Okay, so what is going on with our equestrian and athletics ones that popped up here first? So this is a great example where we as the data analysts did not do anything wrong. We just found a little bit of an unclean part of our data, which is if you see how athletics is written here, it's bracket athletics bracket. And how it's written down here with 2,000 athletes is bracket quote athletics quote bracket. But this is probably the same sport, right? This is probably whoever was typing in this athlete kind of spelled it wrong, right? They left out the quotes. All right, so this is the correct result for this. But what we're gonna do in our next task is clean that up because we know in our minds that this athlete should really be counted. It's really that there's not 2,056 and then 2 in this other event. There's 2,058 of these athletes, right? These 2 should be counted as part of this group. So we can fix that. We can clean that up, clean up that data sort of quality issue with SQL. So that's what we're gonna do in our next task. So before we move to that, any questions about how we got to this query or anyone getting an error message on their query? All right. Okay. Cool. So the next thing that we're gonna do is we're gonna do kind of a modification to the query that we just wrote. Okay, so we're gonna take the query that we just wrote and we're gonna add a component that's gonna kind of clean up that data labeling issue. We're gonna take these 2 examples that we found, this athletics and equestrian discipline where it spelled it without those single quotes. And we're gonna do a case statement that's gonna group these in with their correct group. So athletics is down here with the quotes. If we go find equestrian, it's here with the quotes. So we're gonna use a case statement to kind of clean up this data. This is a great example of data modeling. This is a very common thing that you might do. You might have seen examples of where you are collecting people's email addresses and someone misspells Gmail, right? They write Gmail or whatever, right? You would go through and fix that obviously, because otherwise your email is not gonna send. That's the kind of like text cleanup that you can do with data in SQL. Okay, so to start this query, you're gonna wanna copy paste the query that we just wrote for this. So I'll leave this up on the screen for a moment to make sure you can grab that. But to start our next task, you're basically gonna wanna copy paste this and we're gonna modify it a little bit. Okay, specifically what we're gonna do is we're gonna add a case statement around our case formula around our first column here, our disciplines. All right, the idea with this is we're gonna say, if the discipline equals equestrian with no quotes, make it into equestrian with quotes, like how it's spelled down here. And then if the discipline is athletics with no quotes, make it into athletics with quotes. And then otherwise, just leave the discipline as it is, because if it's not one of these 2 weird ones, then it's fine. Okay, so otherwise, just take the disciplines as it is, end our case, right? And we're gonna name that our discipline or sport column. Okay? So you're gonna copy paste the same query, but we're adding a case statement around our disciplines column to solve for that issue. All right? So for example, we want our athlete who's tagged under equestrian like this. We want their sport to be tagged under equestrian like this so that they get counted in the same group. Okay, so here's a little refresher on what your case statement should look like. It's going to be case when some condition. Okay, so hint, this is the condition that we're trying to solve. Then what should we do about it? What should we put in that place? Okay, we're going to do a second when then for the other case we're trying to fix, right? Our other data label that's a little off. So that's our second when then. These all have spaces in between. To the earlier question, you can do a new line or more spaces, whatever you want to do. And then after else, we're going to tell it what should it grab if it's not one of these two that's sort of spelled wrong. What should it generally grab? Okay, and what should we call that column? Okay, so we're essentially going to have a case statement like this that's going to replace where in this query we just have select disciplines. We're going to have select case something that's going to do some modification to our disciplines column. All right. So what you should do for this, copy paste this, make a new copy, and give it a try. See if you can add a case statement here that will sort of account for this spelling issue in these two situations. All right, I'm gonna give you all a minute to think about what your case, start trying out what your case statement should look like. All right, who has a case statement? Even if it's not working yet, that's okay. All right, what should I write next to my case statement? Got case. What's the next thing? When, very good. All right, case when, right? This is my little template case when something, then something, when then something, something else, something at, right? That's my little template. So I could actually type all those parts out now if I wanted. I could type when, then, else, and. All right, so I've got my initial, this isn't gonna run because I need things in between these, but here's my initial setup. Okay, so when, what's the situation that I want to address? That I run into in my previous data? This result, I had a value in my disciplines column that was equestrian with no quotes around it, right? That's the situation I want to fix because everybody else who's in equestrian had it spelled like this with the quotes, right? So my when is when I see it spelled this way, then spell it the other way. Okay, that's what I'm trying to solve. That's what I'm going to accomplish with my case statement. Okay, so when that column is disciplines, all right, so when disciplines equals, we're gonna do this string, right? So when it equals that string, then do something, and then else, otherwise, it's not that, most of the other disciplines are spelled correctly, right? So if it's not this special case, I'm gonna say just grab disciplines. Otherwise, just grab that column as is. When this column is sort of this typo one, then we're gonna do something we haven't added yet. Okay, but otherwise, like split this out to a separate line for clarification. Else, just grab whatever it normally says in that column, right? Because otherwise, most of those values are fine. And then to rename my column, I'm gonna do as. I could name it anything. I could say as sport or something. I don't have to necessarily name it discipline. All right, I will name it disciplines for this case, but I don't necessarily have to. All right. So this is not gonna work because I don't have anything after my then. And I need to figure out what to put in my then, but I could put anything just to try it. So we're gonna do that. So I'm gonna say horses. This is not what I'm actually gonna have in there. This is something we're gonna try for the sake of this. Okay. So what this case statement is doing is saying when in the column disciplines you find this version of equestrian, then replace it with horses with several exclamation points. Otherwise, grab the discipline, just whatever it's called. And we always put at the end of our case statements, and that's our first column. And then everything else, so lines 3 through 9 of this query are the same as before. So I copy pasted. The only thing I changed is what I'm doing with this first column. And so if you look at my results compared to last time, they look very much the same, except what is different. This used to say equestrian in brackets, and now it says horses with several exclamation points. Okay, now since I am grouping by disciplines, as long as I name this the same as it's spelled down here, so down here it's spelled like this, bracket, quote, equestrian, quote, bracket. If I spell it the same way, it'll group into this group. All right, so I changed the label using my case statement. I changed it from bracket, equestrian, bracket to horses. That's cool. My case statement worked, but it's not really accomplishing what I need to, because what I want to do is give it that same label so it gets included in that same count. All right, so what I want to do is I don't actually want to label it horses, several exclamation points. I want to label it bracket, quote, equestrian, quote, bracket. That's what I want it to be called. Now, notice it looks a little cranky right here because I use single quotes to tell it a whole chunk of text anyway, but this is a chunk of text that has single quotes in it. All right, that's annoying from a SQL perspective. The solution for that is to just add an extra single quote. So what that means is anytime it's looking at a string of text, which anything between single quotes, it's going to read as a string of text. Anything that it's looking at in there, in order to type a single quote within that, we're just going to type a single quote twice. And it's just going to read these two characters as the text of a single quote, not as the end of this string of text. I know that's a little confusing. It's similar to the idea of like escaping a character in HTML, for example. Okay, so all I'm doing is just a little trick to tell it that there is in fact going to be a single quote in the final text. And I'm going to run that. And what's going to happen is horses is going to go away. And then when we scroll down to equestrian, we're going to see that this 246 is going to add in this one that's currently being categorized this other way. So instead of 246, this is going to become 247 once I run this. Right, so let's run this guy. Great. Okay, cool. I see I've got my equestrians. Why are you here? Okay, so this is a good bug to look at. So we've included equestrian here. It has its single quote, so it's been relabeled. All right, did I misspell it somehow? Equestrian. No, delete this. Equestrian. So froze right now. Okay. Give me a second. Oh, there we go. Okay. So now if we go down to equestrian right here, we see that it has 247 and it's been removed from the top. So basically all we did was we swapped the sort of incorrect spelling for this correct spelling, right? And then once we did that, it gets grouped together with its correctly spelled pair. And our total result now has one fewer row. So before we had 52 rows, if we go back to our result from our previous little exercise, we have 52 rows, but one of them was sort of this like spelled wrong one. If we come down here, we now have 51 rows because they've been grouped together correctly. So this is a very common use of a case statement for kind of fixing these little kind of like text typos, little inconsistencies that come up in your data. All right, so we're almost done with this one. We need to do one more thing, which is add one more section to our case statement to account for our other issue, which is our athletics one. All right, so all I'm going to do that, I can do whatever spacing I like. I just like to line up the whens personally. I'm going to do another when then pair, but instead of dealing with this equestrian case, I'm going to deal with this other data error, which is my athletics case. All right, I have athletics here with no quotes. Athletics is supposed to have quotes. All right, so I'm going to add a line. The second line of my query should look very similar. This when disciplines equal equestrian, but I want when disciplines equal athletics, then fix the spelling on athletics. Okay. So if you're following along, all I'm doing is saying, all right, when it's this other case, which in this case is here, this athletics, I think I can even just copy paste this value. Let's see if that works. Yes, great. All right, so when you're looking at the column disciplines and you're running into this particular value, athletics with no quotes around it, then just do the same quick little fix that we did for equestrian. Okay, so here's the same value, but it should have quotes around it because when I look at my data down here, row 7, these 2,000 athletes that are categorized under athletics, it has bracket quote. And so that's the only difference between these two rows. So it should be 2,058 athletes being added all together. All right, so I'm going to make that same fix. So my case statement is still my case statement. It's just a little longer because it has an extra when then. You can have unlimited case statements or unlimited when thens within your case statement. When I have big messy data sets, I often have a query that has like 10 of these where I'm fixing a bunch of little typos and stuff like that. Once that's done, I can run this guy and my whole thing is going to go down to 50 rows. And I can see that my athletics category has gone up to 2,058. I can make that same little formatting tweak here. So I can take my percentage column, just click on it and change the format to %. And there we go. Cool. All right. So if you want to win an Olympic medal, you should not go to the Olympics for road cycling. you should go to the Olympics for one of these sports up here, like rowing, for example, much more likely to win a medal in rowing than you are in road cycling. Cool. Okay, any questions about what we did right here with what we did with this case statement? Anybody get an error or anything with theirs? Or different answer? Right. Okay. All right. So this is kind of taking a little bit of a step back to look at a couple of other pieces, including a couple other components of our data set. All right, so I think I loaded in the rowing and the volleyball data sets into here. So if you look in your data frames, you should see rowing results and volleyball results. So those are results from competitions in those specific sports. So let's do a quick SQL query to just like take a look at those results data sets. We haven't looked at any results. We've just looked at the medals. All right, so this is just going to be a select star from these tables. Let's just take a look. All right, I'm going to select star from rowing results. Limit 20, say. All right, so you can look at the rowing, you can look at the volleyball, whatever is of more interest to you. And we can take a look at what this data looks like. So it has a date, it has a code for the stage, a code for the event, a name for the event. Okay, lightweight men's double sculls, that's the name of a rowing event. All right, it looks like it's got a stage, so they've got the different heats, the repechage, etc. We have the gender, we have the discipline, we have a code, we have the venue, another code, country. Okay, so we've got all kinds of information in our results. And then most importantly, we have the rank and we have the time, right? Because it's going to be whoever has the fastest time is ranked first in each rank. Okay. All right. The other data set that I think we haven't looked at yet is our teams data. So I'm going to come in here and do the same thing. I'm going to just do a quick select star from our teams data. Teams data. To take a quick look at what's in there. Select star from teams data, limit 20. Okay, it looks like we have a code that applies to the team specifically. All right, then we have the country, gender, we got some other specific events, number of athletes, all this good stuff. Okay, cool. So these are two other data sets that we haven't looked at yet. Now, just from looking at these very quickly, from our teams data set, it starts with code, and this code, if we expand this column a little bit, this code looks to me like it's going to be a unique identifier for each team. All right, it's got like some abbreviations. I think this might be archery. So it's got archery, men's team, and then some other numbers, maybe a country code in case a country has multiple teams, etc. Okay, so I've got a country, or sort of a team level unique identifier. And then if I come up into my rowing data, and I think this is true in the volleyball data as well, I have a participant code. Just scroll past, which is here. Okay, I have a participant code, which is here, which looks very similar to my team code down here, right? It's like an abbreviation for the sport, an abbreviation for the event, a dash, country code, number. Okay, so I've got this column that's the same against these two data frames, which means I can use it to join. I can join some data from teams to my results, which is pretty cool. All right. So this is a totally fresh new join from the one that we were last working on. This is going to look at teams and rowing, although if you want, you can use the volleyball. We want to look at of all the results. Goodness. Sorry. Of all the results, we want to look at which. Okay. Of all the results, which country completed the most or competed in the most races? All right, and how many athletes total competed on those teams? Okay, so this is another join, but it's maybe even a little simpler than the one that we just did. We're basically looking at, of our teams data, which is here, our teams data has info like our country, like our number of athletes, etc. And then if we come up to our rowing results, we have our code that we can use to join. We have country here, and then we have our results, right? We have our times, we have our ranks, etc. All right. So what we want to do from these data sets is get, of all those rowing results, which country competed in the most races? All right. So how would we capture from our results? I'm gonna go back up to our rowing results. Which country competed in the most races? Our best candidate column for this is participant country. All right, so we could start with a pretty simple query. We know we want participant country, so I'm going to start with selecting that. Select country. From, I was looking at my rowing results. Great. And let's take a look. Okay, so just very simple query. I'm essentially extracting this one column from my rowing results. But I want to figure out how many races each country participated in. So my results should have one row for each race. So how would I add to this query to get my number of races per country? What formula that we've already used a few times today would I use to get my count of races? You guessed count, you are correct. All right, so participant country, I can do count. I give that a run, I'm going to get an error message. It's going to say participant country must appear in the group by. So I'm going to add a group by. All right, I can either, I think we talked about this last time, I can either, when I do my group by, I can either give it the column name or just which column number it is. So if I say group by 1, it'll just group by whatever the first column is. I could have also typed participant country there, and that also would have worked. All right, so now I have my country and now I have my number of races per country. I can also rename this. I'm going to rename this as num races. Right? Okay. So we've got our rowing results, we've got our country, we've got our number of races. Now, the last piece we wanted to add on to this query is how many athletes total competed on those teams. Now I have the number of athletes on each team in my teams data set. Okay, so to get the number of athletes added onto this, so for each country, I not only want to know how many races were they in, but also how many athletes total. I need to add on my team information. So I need to do another join. All right, now in this case, I'm okay to not include any teams that didn't race in rowing. I don't necessarily need any data about that in this analysis. So I'm just going to do regular join. This is the case where I'm going to do a regular join instead of a left join. Before we did left join because we wanted all of our athletes and we wanted to know if they were medalists. We didn't want to lose them if they weren't medalists. In this case, we just want to look at teams that have rowing results. So we just care about teams that are in both places. A gymnastics team, for example, we don't need. So if we wanted that, we could do left join, start with our teams, do a left join and just add the rowing. But because we only care about teams that appear in both, we're just going to do a regular join. All right, so in this case, I'm going to do a join. I'm going to join on my teams data. And then I either need to add a using or an on should join my team's data. All right, so if they have the same column, I can do using, otherwise I need to do on. All right, so thankfully I did my quick little select star from up here so I can see what they're called. It looks like the team identifier is just called code. And up here, I think it's called participant code. All right, so I will need to do on, so join teams data on, participant code equals code. All right, so I've done my join, and the very last thing I want to do is grab that number of athletes. So I want to add up the number of athletes in total. All right, so I'm going to go back to my teams data frame. Let's see, I think it had a column for number of athletes. It did. It's called num athletes. So I'm going to add up the results of that column. I don't actually think we've done this one yet today, but we did this one last time. Sum, very similar to count. I'm going to do sum num athletes. And I'm just going to give it a handy name like num athletes again, for example. Spell athletes. Right, fantastic. And make sure I'm making sure I'm putting a comma between any new columns that I'm adding. Okay, let's give that a run. Okay, fantastic. So it looks like we've got, for each country, for Australia, we've got races, we've got athletes. It makes sense to me that there's a lot more athletes than races because in rowing, their boats might have 4 or 8 people. Might be a lot of people in an individual race. So this is looking pretty good. Cool. All right, the last part of this is to filter this down. So essentially add a where clause to this query to see which teams, so we run the same query, but just for teams that ranked 1 in their particular stage or event. All right, so if we do that, all we would do is add a where. Now your where is always going to come after your join. So if you have a join and you need to also add a where clause, the where is going to need to go after. Okay, so this little chart I gave you at the beginning, this thing that's sort of like when you can use different pieces of your query, this is also the order that they'll need to go in. So if you have a join, the where has to go after it. It's also the order. Okay. All right, to come back here, I'm going to do where. So I want to look for the ranking column. What is my ranking column called? So I'm going to go back to my rowing results data. Looks like it's just called rank. All right, so it looks like each race, you know, has maybe 6 boats that are racing. They rank 1 through 6. So all I'm going to do is a simple where rank equals 1. So we'll say how basically of this query that we ran before, how many of these races are cases where they're just ranking number 1. All right, very cool. This is also a case where I might want to sort because I might want to see who was in the most races or race stages where they were ranking number 1. So I might want to do an order by my num races. This is a case where I probably want to see the biggest number first. So I'm going to do my descending. My default order by is always going to be ascending. Descending, so it's in reverse order. Okay, and I see that the Netherlands most commonly ranked 1 in their various events, which is super cool. Oh, Netherlands. All right. So this is another join, right? Earlier we did a left join and then we kind of did a bunch more work on that query. This is functions very similarly, but it's just a join instead of a left join. Any questions about this query? Anyone getting any errors, anything like that? Okay. All right. Okay. I think we have time for maybe one more kind of speed round on case statements. All right, this is going to be our last data model of today, which is going to be called medals total. Okay, so we're going to look at our medals data set, which we haven't used yet, which has a row for each and every individual medal that was run at the Olympics. But you can imagine the most common thing that for example, news might want to report on is medals by country. So we're going to create a data model that's going to count up the metals by country from our metals data set. So anytime we are starting a data model, first thing you want to do is go to your source data and select some rows so you can see. So in this case, we're using our metals data, which we haven't looked at yet. So I'm going to say select star from metals data. And I'm just going to eyeball what this looks like. All right, looks like this data set has a metal type, metal code, metal date, name, discipline, event, code, country, great. All right, looks pretty straightforward. So what I want to get is country, total number of metals, and then I also want to get the number of metals that are gold, silver, bronze for each country. Okay, there are two ways I could do this. First way I could do this is right here, which is just a very simple country, metal type, and then total count. And then I'm grouping by my country and my metal type. So this is going to create 3 rows for each country. So for Belgium, there's going to be a row for gold, a row for silver, and a row for bronze. For Italy, there's going to be a row for gold, row for silver, row for bronze, etc. So this technically gets me my same like information as I've laid out here, but it's not in 1 row per country. It's a few rows per country. This might be a case where I maybe want to order by country, for example, by order by country. I can see, for example, Algeria looks like they didn't win any silver medals, so they just have 2 rows. They have a row for gold and a row for bronze. So this data answers the question that we just posed, but this data model isn't especially like straightforward to look at for like someone who's a little bit less of a data person, right? They might be expecting just 1 row for Algeria and then to see how many metals of each type that they want. So this is a very simple query. This kind of works, but we're essentially going to write a slightly different query that's going to get at the same information in sort of a more clean data model way. Okay. So the way to do that is with case statements. So we're basically going to say, instead of making metal type a column, we're going to add some case statements where we count up the case when the metal type is gold, the case when the metal type is silver, and the case when the metal type is bronze. All right, so here's what that code looks like. All right, so in this case, as compared to our one above, let me hide our little results. All right, so here's what we wrote before, right, where we selected metal type as a thing to group by. Here we did it with some case statements. Okay, so pretty straightforward. Count when type equals gold. That column is going to be called gold metals, and then do the same for silver and bronze. And the result of that query is this table, which is a lot easier to read, especially if I'm trying to hand this to someone who's maybe trying to report on the news or write up something for their blog, right? This one makes a lot more sense. And when you have this one, you can sort it by, for example, total metals, or by gold metals, or whatever you want it to see, and you can see all of your results, sort of a more intuitive view in this order. So just to kind of cap off our discussion on data modeling, this is basically the same data as this query produced, right? But we went to a little bit of extra effort to add in these case statements, to add in these extra columns, because that's going to be easier for our end user. An extremely common question people ask about the Olympics is, how many medals did my country win? How many gold medals did this country win? Which country won the most gold medals, right? Those are the kinds of questions people tend to ask. And so this second one that we did with all these case statements makes it much more straightforward for someone to answer that. So that's what we're trying to do with data models, give them something nice and easy to refer to. All right, I know we covered a lot of stuff today. We talked about just kind of all of our query stuff from last time. We talked about what does data modeling mean. We talked about joining data frames together. We got all kinds of stuff. I know that was a lot. There's a few more exercises that we didn't get to in our session today that are at the bottom of your hex doc. They're all very similar to some of the exercises that we did in this class. So if you want to take a stab at those as sort of your own little practice exercises, you totally can if you just scroll a little further down. And then just wanted to quickly remind you all of what is coming up. So like I mentioned, the next 2 weeks of this workshop. We're off next week for the holiday, but the next 2 weeks are gonna be Python. So it'll be similar kind of 2-week session as these first 2 weeks. So we'll, if you've never written or seen or heard of Python before, you're gonna be totally in the right place for the 18th. We'll do totally kind of like intro. On the 25th, we'll get a little bit more into using it for some of these same use cases that we're using SQL for. All right, and then in our last week, we'll kind of put it all together. These slides will get shared out on the Digital Lounge website along with the recording, but I just put a few kind of little resources here. The first is a blog post about kind of what it means to do data modeling, some kind of like best practices for putting together good data models that make sense. All right, so I definitely recommend you check that out. And then these are a few of the same recommendations from last time, just more good spots to learn SQL, navigating hex, all of that good stuff. Which I think brings us right to time. So thank you so much. I'll hang out for a few more minutes. If you have another error message or a lingering question, I'm happy to chat for a few more minutes. Thanks, everybody.